Sketch the region corresponding to the statement, the probability that your z-score is greater than -1.5 but less than 0.8. So I'm going to be a little bit smaller than 1 standard deviation above the mean, and I'm going to be a little bit further than almost 1.5 standard deviations below the mean. So I'm going to draw myself my normal curve, and I know that the inflection point is where 1 standard deviation is, right? So the inflection point is roughly right around there and right around there. So that would be roughly 1 standard deviation on either side. So I have to have a z-score that's smaller than 0.8, so just a little bit smaller than a z-score of 1. So this will be roughly 0.8. And then I have to be, if that's 1, then that distance would be approximately 2, right? So let's draw a little bit more information here. So this distance is 1, so that same distance to the left is -1. Go that same distance again, that's -2. So we need to be at -1.4, so roughly right around there. So here's my z-score of -1.4. Whoa, let's see if I can write that cleanly. -1.4, and here's my z-score of +0.8, and so we're just going to shade the region in that interval. So then it says, use the z-table or the inverse normal command on your calculator to help you answer the question below. Sketch the region corresponding to the statement, the probability that your z-score is bigger than -c but less than +c is equal to 0.3. So we got to stop and think about this for a second. Let me just go ahead and erase this. I've got a normal distribution, and I'm going to go c to the left, and I'm going to go c to the right of the center. And I know that this central area is going to be 30%. Okay, so I drew that a little bit too big, but that's okay. So this center area here is 30% of the data, which means I've got 70% of the data left in each tail. Well, 70% of the data to be split into each tail. So if I take 70% and divide it by 2, then that leaves me 35% for each tail. So 35% of the data is down here, 35% of the data is up here. So then that makes this z-score a given percentile. I know that this is the 35th percentile. So I can find that z-score in my calculator by doing the inverse normal command. So I can go distribution, inverse normal, and I tell it the area under the curve that I want. Well, that's going to be 0.35. Since it's a z-score, then we're on the standard normal curve, so the mean is 0 and the standard deviation is 1. And we get -0.385. So our z-score here is -0.385, which means our z-score up here is +0.385 because the distribution is symmetric.